Hi guys, so we learned a little bit about substitution pertaining to simultaneous equations. Now we're going to learn a little bit about eliminations, right? We actually want to solve for x and solve for y, right? So what we're trying to do is basically eliminate either the x or the y terms in order to solve for, so let us say we're eliminating the x in order to solve for the y, or vice versa, eliminate the y to solve for x. So we have an equation 5x plus 3y is equal to 31. 2x plus y is equal to 12. Now we have a single term here, so we could actually use substitution to find for this, but we're not doing substitution just yet. We're actually looking to eliminate. So the easiest thing to do, since this y doesn't have a number in front of it, or the number in front of it is understood to be 1, whenever you have a single term, let us say a single term is a 1 is understood to be in front of it, as well as it is understood to be positive, right? So we could actually put a 1 here if we liked. Okay, so continuing, the first thing we want to do is to label our equations. Equation number 1 and equation number 2. The second thing that we want to do is we want to see if there are any terms, the terms x's and y's, if there are any numbers in front of the terms that are the same. No, they are not. Now, for elimination, we are trying to get rid of these numbers. In order to get rid of them, the numbers have to be the same. In order for the numbers to be the same, we have to actually multiply them by some number. So let us say if we were going to change this equation, right, or this one, we could say, if we had to eliminate the 5's, we say, okay, we can't change this 2 to 5 and we can't change this 5 to 2. So we're looking for the lowest common multiple, right, yeah, LCM, right, of 5 and 2, which will give us 10. So we know that these two equations, we would have to change these x's to 10. So we would actually have to multiply this entire equation by 2, because 2 by 5 will give me 10 here, and this entire equation here by 5, because 5 by 2 will give me 10. Now there's a simpler way of doing this. We have here in front of y 3, and in front of the lower y in equation number 2 we have 1. So what we can simply do to this equation, equation number 2, is multiply it by 3. So if we do that, let's see, 3 by 2 will give me 6x, 3 by 1 will give me 3y, and 3 by 12 will give me 36. We've done something to this equation. And just like being married, when you get married, your name changes. So this equation is no longer equation number 2. We've done something to it, so it's now equation number 3. Let's rewrite equation number 1, so it's a little closer to us. 5x plus 3y is equal to 31. Equation number 1. Now you realize that the 3's are the same. So now, since the 3's are the same, we can actually get rid of them. Now there's a rule. If the signs in front of these numbers that we want to get rid of are the same, we are subtracting the two equations. So signs the same, we're going to subtract. Now if the signs were different, let us say this was a positive and this was a negative, we would have to add the two equations. So signs different, we would have to add the two equations. So let's put EQNS here, EQNS here, right? So we know that we're adding the two equations. Now let's continue. So the two signs in front of these two numbers here, they are the same. So signs the same, we have to subtract. So we're subtracting. I like to put a little subtract sign outside to remind myself, right? So we have 6x. So I'm going to write it 6x minus 5x. So 6x minus 5x. 3y minus 3y, they're going to eliminate. They're going to cancel out. So we don't need to write it back. It's equal to, so we're following each term in the equations. So the x's, the y's, and then the number after the equal sign, right? So we just subtracted the x's, the y's have been eliminated, and now the numbers, so 36, subtract 31. Now, we don't need to label anymore because we've used the equations, right? So we're now starting to solve. Well, you realize we've just boiled down to just x's. So we're going to start to solve for x. So 6x minus 5x, 6 apples minus 5 apples. Don't let the letters and numbers confuse you. 6 subtract 5 will give you 1. 1x is equal to 36 minus 31, regular subtraction. 31 from 36, 1 from 6 will give you 5. The 3's will go out. So we end up with 5. So 1x is equal to 5. This 1x, as I said before, 1 is understood to be in front of the letter. So we don't have to rewrite 1x. We can say x is equal to 5. So we've solved for x. So we're going to substitute. SUBS means substitute. Your x is equal to 5 and, I shouldn't say and, into any one of these three equations. So we have equation number 1, we have equation number 2, and we have equation number 3 that we could actually use to substitute this x is equal to 5 in. I would actually use equation number 2 because I know the y started off with just a single term. So equation number 2 is 2x plus y, or 1y, is equal to 12. When I say substitute x is equal to 5, I mean wherever it is that I am seeing x in this equation, I now put 5. Now, when we have numbers like this is actually 2 multiplied by x. So if we put this 5 in the space of x here, or substitute it, we don't just put it into the equation. We're actually multiplying it. So what I will do is I will put brackets around it, because brackets means that I'm multiplying by the term in front of it, plus y is equal to 12. 2 by 5 will give me 10. 10 plus y is equal to 12. Now, I want to solve for this y. So it means that I have to move everything else from on this side. I need to move it over. This is understood to be a positive 10 because it has no other sign in front of it. If I'm moving this 10 from one side to the next, the sign is going to change. So I'm going to rewrite what I have left on this side, which is positive y, or just y, is equal to 12. He has already been here, so we're just writing him back. And this is the person who's going to be visiting. So their sign changes. So y is equal to 12 minus 10, which will give you 2. So we know that x is equal to 5 and y is equal to 2. Pretty much, very much straightforward. If you have any questions, you can always message me. Let me know. But simultaneous equations, as you can see, is a breeze.